Okay, so today there's really two main things that you need to work on. The stoichiometry and particle model practice, that the papers by the door that you should have picked up. Those need to be turned in to the sub before you leave today. Then there's the Hydrate Inquiry Lab, which you're going to look at with your group, get started on, but you're not doing the lab today. We'll do the lab on Tuesday, but you have to do a little bit of preparation for that. And I've recorded a separate little video that I posted in that Hydrate Inquiry Lab assignment just to help make sure you know what's going on with that. So here we're going to focus on the stoichiometry and particle model practice. And it starts off with just 5 stoichiometry problems here for you to do. Read them carefully. I have all of the balanced equations ready for you so you can focus on the stoichiometry. I've even given you most, if not all, of the molar masses that you need along the way. Here, just pay attention. I'm starting off by telling you what's in excess, asking you to find a specific amount of a chemical there. And by the end, I'm giving you the amounts of multiple reactants. In fact, this reaction has 3 reactants. I'm telling you how much of each of them you're starting with, and I'm asking how much of a product we can produce there. That is going to be a limiting reactant situation there. Slightly less complicated limiting reactant situation in number 4 as well. But normal stoichiometry problems to keep you practicing working with those. Once you get to the second page, then these turn into multiple choice stoichiometry problems. So for all of these, I'd like to see your work shown in the space that I've allocated you. If you don't have enough space here in this paper, you can get some notebook paper, do your work there. Make sure you staple that to this packet to make sure that I can match that up with the work that you've done and number each of your problems to match the number of the question that you're working out there. But do make sure that you circle an answer here, even if you do some work other places. By the time you get to the end of that second page, the back of the first page, you're going to start to see a little bit of particle model stuff drawn for you. You're going to need to interpret what's happening with these X and Y elements as they're coming together to form those products. So the left side is the reactant side, the right side is the product side. And you'll notice there are some, excess reactants still floating around there that haven't formed molecules, but you should be able to look at how many you've started with and what molecules you've ended with in order to be able to form these molecules and choose a correct reaction that goes with what you're seeing here. Then by the time that you get to the third page, our focus is going to be on the particle model stuff. You are going to need to balance the equations that I give you, and I tried to remind you to do that. And then I've introduced you to that same kind of reactant and product type of reaction, except this time our reactant side here is blank. So you're going to look at the products that were created from this reaction. This is all part of number 1, so it's all going, with this first reaction here. And what I need you to do is following the key that I've left you, understanding what we've made here and how many of those CO2 molecules we've made here draw what those reactants would look like in the correct amounts. Similar stuff happening in number 2. I've got a reaction. You need to balance that first. That's going to help you with what you're doing down below. And then I've given you the reactants, and I want you to draw the products. Notice how I have told you the H2O and CO2, what they represent, what they look like there, so that it's not just 3 random circles connected to each other. One is a little more of a V, one is more of a straight line, colored, of course, to match the key that we have here. Then once we get to number 3, it starts off kind of the same, except you are going to be writing the entire reaction. Here we've got hydrogen and nitrogen forming ammonia. And I've told you what ammonia is. You should be able to figure out and remember what hydrogen and nitrogen is, but I will remind you they're diatomic molecules if what you saw down in part B wasn't enough of an indication of that. So write the equation and balance it, and then you're going to do a lot like what you did in number 2. Look at my reactants and draw what is going to form as the products. But what you're going to notice here, it does kind of continue on. We've got 2 kind of follow-up questions after you draw your particle model stuff on the bottom of that third page about what was the limiting reactant. So this is already a kind of hint that probably not everything from that reactant side is going to get used up. One or the other is, but you're probably going to have some leftover stuff there, kind of like that first example in the multiple choice section. And then be careful and count how many molecules of that excess reactant are left over. Not the limiting reactant, we won't have any of that left over. How much of the excess reactant, specifically molecules, are left over of that. Then it continues the same. 4 is basically the same, different reaction. Pay attention to the words. It tells you what you're writing out in the balanced equation. Make sure it's balanced before you predict those products. And then, once again, limiting and excess. This time we're not seeing the products. You're drawing the products again. Same kind of thing in 5. Same kind of thing in 6. 7 here kind of goes backwards. You're still writing, balancing an equation, but then I'm showing you the products, kind of like I did at the very beginning, and you're going to draw out the reactants, including, make sure you notice there might be a limiting reactant, so you might have some leftover reactants in that product side there. And this one, you can, since I'm showing you the products already, this might be a good place to start with question B, where you're making a note of how much of that excess reactant is left over, kind of working backwards to figure out how much of the reactants you would be starting with from there. Then, kind of like with the last activity, we move into a multiple choice type format where you're going to be using the same A, B, C, D, E answer choices for 5 different types of reactions to label each of these types of reactions that you see in these particle models here, as well as in 5, this is another type of reaction, so we're still using A, B, C, D, E. And then 6, we're going to look at if number 5 ran to completion and had that reaction happen. And I made a note that if you look at page 1, example number 3, and I guess page 1, I meant the first page of all this particle model stuff. So I'm talking about question number 3 here. This is the reaction that's happening there. So if that reaction is happening and goes to completion, almost there we go. And if this reacts to completion according to that previous reaction, then which of these diagrams would be the correct representation of what we're forming? And then we get to some multiple choice questions that have their own multiple choice options right there. So read each of these carefully. They all come back to this initial particle diagram and, gets into some of the simple basic stuff here, and then some, slightly more complicated situations, but nothing too bad. Finishing up with you drawing a full reaction out, starting with the reactants, ending with the products. I tell you exactly how many of everything, 8 molecules of SO2 and 5 molecules of O2 are what should be in your reactant side, and then they are forming SO3. You might want to write and balance a reaction there just to see what the normal reaction would be. It's not really what I have points for. I just wanted you to show me the stoichiometry, show me that reaction happening in the particle model with those circles. So, put all of this stuff on your paper, do the best you can, support each other in your groups. Hopefully, if you were a little confused about what to do, that this helps. And try and save at least 20-30 minutes at the end of class to work on that Hydrate Inquiry Lab with your group.